Right, so I'm just in the middle of setting up this Space Riders. Definitely need to look at this mains wire before anything else. This was taped on the top of the glass, so I'm guessing it's got some potentially serious issues with it. This mains lead, as you can see, is not at all even slightly safe. So I think before I put the head on, let's see if we can turn the light on. There we go. It's actually reasonably easy to do the job while the head's off, so that's what we'll do. Power supply is right at the back here, which is going to be awkward for working on, but yeah, we'll just get a new mains cable. It just needs some crimps to go on there. Right, the only cable I've got in stock is this Overkill 1.5mm, so we'll use that. I've crimped on some new connectors, so we basically just need to get those cable ties, they're screwing cable ties, we just need to get those out. There's two of those holding it in at the bottom, and then we can just plug it in. So I've got the new cable connected, I just need to tie down the wire. Once I've done, I've just pulled these connectors out, as this lower one looks like a voltage selector plug, so I'm just going to get the manual and check that that's actually wired for 240 volt, and then we'll put that back in. Again, it's one of those things that's easy to access without the head on, so we might as well do it now. Right, so according to the manual, this is wired for 220 volt, which is European. This is going to be fine. There doesn't seem to be a 240 volt option. We'll probably work one out by looking at the transformer taps, but 220 will be close enough. And I need to go and find a new plug, as I won't be reusing this one. Right, so Atari were a bit insane when they made their pinball machines and decided to put the back box lock on the back of the back box. I don't think any other pinballs do this, because it's obviously not convenient to get access to. So you've got this little access panel here, and then you've got some metal slides which you move here to allow you to push the back glass up and release it. That is super inconvenient, obviously. So there we go, that's the head installed. It's with Atari being crazy, they've obviously done the lighting in a different way from everyone else. And we've got these 510 volt American bulbs in the back. So fortunately the game's come with a few spares of those. We've got this one connector here. I guess we need to route into here somewhere. I'm actually not sure where that plugs in, so hopefully we can access it once we lift the play field. As I'm going to put the glass in now and then secure these metal sliders and hopefully never have to take that glass off again. And there we go, that's the machine set up. I have to say the whole height and angle of this machine is a bit ridiculous compared to a normal one. You can't actually see, look how high it is at the front. It's got really long legs, and I've got the back legs adjusted up as high as it will go, but it still looks like almost a pool table. It's pretty flat, so I might end up swapping the legs on this and put some shorter ones on the front. Maybe we can get a bit more angle. I do like games to be faster, but we'll have to see how strong the flippers are, as I've not owned the Atari game before, so I don't know yet. So the glass comes out the same way as pretty much any pinball machine. Got a little locking tab, although it's huge for some reason. But I haven't worked out how to release the playfield, so I need to have a closer look at that. Okay, so it just pulls straight up, there's nothing locking it in place, it was just difficult to do. One thing I have to say that's really nice, because this is a wide body, it's actually got a prop on both sides, so you're not bending the playfield. Williams and Bally never did this, and it's always dangerous to prop them up on a prop with a wide body. You need to put a stick of wood in usually to make it safer. It's going to be a nightmare to work on this game, because power supply is at the back corner there. Main board is here, no cover on it, we need to get a cover for that. If you get screws and bits of metallic flake dropping into the board, that's going to kill it. And that's some sort of aux board. Not sure, I don't know anything about Atari games yet. We will work it out as we go along. So first things first, let's take all the things out that shouldn't be in here. There's a bag of spare bulbs and stuff there. So it's absolutely crazy looking at an Atari game for the first time compared to literally every other pinball machine that exists. Most pinball machines have a lot of similarities in the way they work. Gottliebs are a little bit weird, but this is just like nothing else. So we've got some fuses here on a service panel. There's a whole bunch of fuses there at the back. You can see the bridge rectifiers are there on that back plate. Huge capacitors there. We've got a big ribbon cable that goes up the playfield, and that's where, so the player displays and the credit display are on the back of here. Again, that's something really weird. Oh, it looks like looks like this flipper has been on fire at some point. Obviously that coil on it, that looks fine now. Just all the mechanisms, like look at these flipper mechs, they're like no other flipper mech. All like the kickers, the targets, everything, it's all weird compared to what you'd be used to on any other pinball machine. Oh yeah, there's this like a fused daughter board here that goes onto the CPU board, so it looks like potentially every single solenoid is individually fused there. But it looks like someone must have had the wrong fuse in for that to happen at some point. Not sure what this board is. Is it like a secondary power supply or something? It looks like it might have big voltage regulators on it or something. I can look it up in the manual, find out what it is. But yeah, this is absolutely crazy compared to what... I mean, even just look at the coin door. No other pinball machine has a coin door like this, where you drop the coins in like this, straight down. Crazy. Right, back on the Atari Space Riders. I can't remember where I got up to filming this. I think the last thing I did was replace the power cable. So before I power anything up, as obviously this sort of thing's rare, there's not very many Atari games around, I'm going to pull the board out and inspect it, make sure there's no bits of metal or anything shorting out on it. Clean up the connectors. So we've got one connector off already. But I'm going to pull all these off. That's actually very loose. It probably needs new pins. I'm going to clean all these and inspect the board. Right, so I've got the board on the bench and I've just been going through checking a few things. One thing I've been doing is basically pulling out all the ICs that are in sockets, cleaning the legs and reseating them, as I don't know if there's anything wrong with this board, but a 1970s game that hasn't been used for a very long time, there's potentially can be connection problems with the sockets. So just trying to eliminate any issues so we can maybe get this to boot up first time. Anyway, I have actually found a problem, or at least I'm fairly sure it's a problem. Yeah, so this IC here was a 7.4 series logic, so that's going to be the ground pin. So yeah, that is a problem for sure. So this one, I've taken it out of the socket, and I don't know how well you're going to be able to see this, but that pin there, it's like it's been melted with a soldering iron, so you can't actually put the pin into that hole there. So there's nothing. So that means that that leg there, on the bottom corner, that's the ground. So that's not connected. So this chip is not being powered up at all. So that is not going to be working. So that, for certain, needs fixing before I've even tried to power this game on. So this is how it was when I found it. So that pin is basically sitting outside of the socket. I mean, has someone done this intentionally? I can't imagine so, because that won't work. So let's get a new socket on that. Right, so when we look at the schematics, this F5, which is the 74145, is responsible for reading the second bank of dip switches. Now, I don't know how important those dip switches are, but with that ground missing, that was clearly not working, so the game wasn't reading those switch settings at all. So, interestingly, we are going to be fixing faults before we've even powered the game up. Right, so I've removed that socket with the desoldering gun. With these older style circuit boards with a no solder mask, there's an extra step you need to do. So basically, after you've removed the socket, you just basically need to run your iron over like so, just to clean up any solder blobs, because as you can see, there's no solder mask protection, and there's very, very thin gaps between the traces and the pads, and it's very easy to get a short. So let's say you just give it a good clean up like so, and that just makes sure there's no shorts there. This one there needs a little further cleaning up. Yeah, such a fine tolerance. Look at that little gap there. Can't focus any further, but yeah, it's really important to make sure it's clean and there's no little whisks of solder. And then after that, we can fit the new socket. Right, so looking at the reverse of the PCB, we can have a look at what has been replaced on this already from the solder mask. Now, I haven't cleaned the flux off yet here, so you can see where I've just replaced this socket, but we'll clean that up shortly, and we can see that these chips here have been replaced in the past. Other than that, no other ICs. We've got some drive transistors that have been replaced, and the legs are actually very long, so we're going to trim those down. Same here, we've got the components been replaced there. Got some something that's been replaced there. So yeah, not too much has been done to this, thankfully. So the board's in reasonably good condition with no damaged tracks as far as I can tell. So let's just give this a bit of a clean up, trim those legs, and then get the flugs off. So yeah, while we're on the back of the board, we're just going to clean up these edge connectors with a fiberglass pen. So let's just show you how that works. Not sure how well this will show up on the camera. But you can see that is now a little bit shinier than the rest. We can go a bit further and get those black marks off, which I will do this off camera. I'll go through every single one. Right, I've unscrewed this fuse aux board so that we can get to this connector and clean it. As you can see, it's quite dirty, that one, and also this one's partially covered up by the fuse board. While it's out, we're going to check all the fuses are the correct value. I believe they should all be 2 amp slow blow, and I think already I've just seen one that isn't, so let's definitely check that. But yeah, let's clean these connectors first. Right, I've removed 4 fuses that are the wrong value, the worst one being a 5 amp. I'm going to say they should all be 2 amp, so I'll go and find some new fuses to put in that. And the next thing I'm going to do is I'm going to check the resistance across the fuse holders on all of these to make sure none of them have got high resistance. I think they're in reasonable condition, so they should be okay, but I'm going to check them anyway while we're here. So it seemed I didn't have enough 2 amp fuses in stock, I only had 3. So I thought I would see, are any of these fuses spare, or is everything used? So I've gone through the game manual and I've written down what each one does, and it appears that 3, 7, 9, 10, 14 don't do anything. So I've relocated some of those to fill in the slots that are needed. I've done a resistance check across the holders, and the ones that I've marked with little blue X have higher than 1 ohm resistance. So I'm going to take the fuses back out, clean both the fuse and the socket, and see if that improves things. If not, then we'll have to replace the sockets. And after cleaning the sockets and the fuses, everything is below 1 ohm now, or at least the fraction of an ohm. So I don't need to replace any of those holders. So we can go ahead and screw this back onto the board now. So before putting this in the game, I want to test if this regulator is working. So basically what happens is, in the transformer block, there's a bridge rectifier that rectifies 12 volts into roughly 10 volts unregulated. That 10 volts unregulated goes into this voltage regulator, which creates the 5 volts for the board. So I've had a probe around on this connector here, and I've determined that the second pin is the ground, and pin 1 appears to go to the regulator. So I'm just going to double check that visually. And if so, we can feed 10 volts in at this connector and then test it again 5 volts out on the rest of the board. So I've found some convenient places to hook the power supply up that connects directly to this connector. So we've got one on this diode and one on this capacitor. I ramp the voltage up slowly. Once we get to about 8 volts, that's the maximum. So I'll just turn it on now. This is the maximum current it draws. So it draws 2.5 amps at 8 volts. And at that stage, I can't show you because I've got no hands, but I basically checked across some logic ICs. And we're getting 4.9 volts. That seems to be the maximum it regulates at. So the regulation circuitry seems to be working fine, which is good news. Right, so I thought the next thing to do would be to basically check to see if we're getting activity, and also check that there's no coils shorted on, there's no drive transistor shorted on. But when I touch my logic probe onto the board, bear in mind it's not powered up currently, it's pulsing. Why is it doing that? So anyway, I've gone back to the power supply, I've turned it off. I can't aim with through the camera. There we go. Something's wrong with the earth on this power supply. Is this one okay? Oh no, what's happening? Well, there's an earth issue here. I need to find out what's going on. Yeah, I think I've lost the ground on my jammer test rig, so we're not using that for the minute. We've got a scope on. I've soldered the ground of the scope onto the board, so I've got a common reference, and I've basically just been going through probing a few things. So if I turn this back on, we've got some little test points here for address lines, so we can just have a look and you can see we've got activity, so the board appears to be running. Additionally, if I press the reset button there, the activity stops for a brief second, then starts back up again. So it looks like the board is at least partially running. What I want to do is, I can't remember which connects to which, but I think this is the switches here. I want to look for switch activity. There should be some strobe lines, and the same for displays, and we'll see if there's any actually activity on the external outputs. I can't test if any of these are grounded with the scope, obviously, because it just shows me a ground line when it's at ground, so it's not showing me anything different. However, I would have hoped that these would be floating high when they're not active. I guess you need a coil connected for that to be the case. Right, so at this stage I've seen enough activity on the board to assume it's at least partially working. It seems to be booted. There is activity on the outputs, on the drives. I've reconnected the fuses. I've checked, I've done a resistance check, basically checked there's no shorts to ground on any of the output transistors. We also replaced that socket on that IC that reads the dip switch. I think that's everything we can do. I've also tested the electrolytic capacitors. There's not many on here, but they appear to be in perfect working order, so we don't need to replace any of those. So yeah, I think what we need to do is test the voltages in the cabinet, particularly the display voltages, before we connect those displays up, and we can see if we can get this game to boot maybe. Right, I've got the board back in. One thing I thought I'd do is check the rest of the cabinet fuses. So out of these front ones, the line power fuse, which is there in the middle, that should be 4 amps low blow, and it was a 7 amp. If you've watched any of my videos, you'll see that every single pin machine I work on has the wrong fuses in multiple places usually, so I'm going through and correcting all of those. There's a bunch of fuses on that power supply at the back, just there. However, please note, it's actually not possible to access them when the game is in a line of pins, as this one currently is, even with my stepladder. So I'm going to have to pull the game out to be able to get that from the side. So that's a bit of a bad design on Atari's part. However, I have to say, well, the thing is a good design is the quality of these Atari cabinets is pretty good. You can see it's all made out of real plywood. Lots of bracing, solid bottom rather than the flimsy board you get on some of the Bally games. So quite a nicely made cabinet, as obviously Atari are quite experienced in the world of video games, and they've carried over a lot of their experience in this pinball machine. Right, I've moved the game so I can get to these fuses, and I've just started pulling them out, and already I've spotted a problem. Unfortunately, the camera doesn't line up with where my fingers actually are, so I can't. Someone soldered a piece of wire across this one, so this is now a 100 amp fuse instead of a whatever that's supposed to be. So we need to replace that one for sure. I need to find out what these all should be. I have no idea why this is the case with pinball machines, but as I keep saying, every pinball I work on has loads of the wrong value fuses. I just found another one. This is the logic power fuse. It's got a thinner wire wrapped around it, so that's a 50 amp fuse instead of a 100 amp like the other one, like this one. So that's 2 more to replace. Right, so we've done some mild work on the board. We've checked every single fuse. We've replaced a lot of fuses. I've checked those just there as well on the lamps. I've checked for shorts. There is no ground on this cab, at least there's no earthing on the metal. But I've made sure nothing is shorting to earth which is on this frame. So I've done everything I can reasonably test. We obviously need to test voltages going to the displays, but we know the board voltage is going to be okay because we've already tested the regulator on the bench. So I think we can give it a fire up. I think it's going to be okay. Well, at least I hope it is. So let's go give that a try.